And finally, your two basic trig functions from which all other trig functions can be constructed. And technically, you only really need the sine function because cosine is just the sine function shifted over by pi over 2. But it's easier to just know what cosine is as opposed to constantly thinking of cosine as a shifted sine function. Probably more than you needed to know right there. But let's go sine of x. All right, so this is also called a sinusoidal function. So a sinusoidal function is anything that waves, anything that's periodic. So our sine function, f of x, is sine of x. So I went ahead and inserted into the notes your unit circle. For all of you who don't remember or it's been a while, this unit circle will not be provided for you in future situations. So I actually, on the blank ones, I should probably edit and take that out. I think I'll do that. But really, the most important things you need to know are called the quadrant angles. So when your theta is 0, so this is our unit circle. These ordered pairs, I don't like this. It really should be cosine of theta, sine of theta, right? And these angles here are our thetas. So you need to know what sine and cosine is at 0. You need to know what sine and cosine is at pi over 2. You need to know what it is at pi. You need to know what it is at 3 pi over 2. And then you need to know what it is at 2 pi, which is the full circle, right? Those are things you absolutely must have memorized. So for instance, what is sine of 0? Well, sine refers to the y values, right? So how high? Sine is how high. So at 0, sine is, I probably shouldn't pick pink. That's too difficult to see. Let's do, that doesn't help either. All right, that seems too light. I need a happy medium. How about here? Is that okay? Right. Sine of 0 is 0. Sine of pi over 2, that's 1. Sine of pi is back to 0. Your y value is back to 0. Sine of 3 pi over 2, down here, your y value is at -1. Sine of 2 pi, you're back at 0 again. If you know those 5 points, if you can graph those 5 points, you can plot sine of x. So in fact, I'm going to, in less detail than most, I'm going to come down here and it says graph again. So what does your sine function look like? Those are your 5 handle points. Sine of 0 was 0. Sine of pi over 2, let me make this nice and fat. Sine of pi over 2 was 1. Sine of pi was 0 again. Sine of 3 pi over 2 was -1, and 2 pi was 0 again. And so you can see our sine function basically looks like this. And it keeps going back up and waves back down. And then likewise, right, if you were to work backwards, what's sine of -pi over 2? Well, sine of -pi over 2 is the same thing as sine of 3 pi over 2. So it's going to be -1. Wow, okay, we're just going to go with it. Sine of -pi is 0, right? And so -1, and then 0, and then +1, and then 0. And so our function again, that is sine. Sine starts at 0 and it takes 2 pi. It takes a full circle to make a complete cycle here. So this is our sine function in its simplest form. Now, because I thought it was a good idea to review some of your other trig identities or trig facts, maybe we'll call them trig facts. What is sine of pi over 6? So, guilty confession. I don't think about things in terms of radians. I think about them in terms of degrees. And I know that pi over 6 is smaller, so that's my 30 degree. So I think of my 30, 60, 90 triangle. Whoop, whoop, whoop for pi over 6, right? My 30 degrees, this is 60 degrees. That means if my hypotenuse is 1, which it always is in my unit circle, right? Sine being opposite, well, that's going to be half, right? Because my 30, 60, 90 right triangle property. And indeed, it is half. And that's why this is bold. Because that is easy to plot, right? If you can see where pi over 6 is on your x-axis, halfway between 0 and 1, that's a nice, easy kind of marker. Pi over 4, sine of pi over 4 is rad 2 over 2, which is approximately 0.7. Sine of pi over 3 is rad 3 over 2. That's approximately 0.87. I wouldn't use either of those to plot points and graph. I would really only use pi over 6 because 1/2 is easy to plot. Likewise, 5 pi over 6, way over here, again, is where you're going to get y is equal to 1/2. And so then which two other angles are going to be easy to plot on a grid? Well, 7 pi over 6, not 2, 7 pi over 6. 7 pi over 6 is going to be negative 1/2. And then 11 pi over 6 is also negative 1/2. And those are also easier to plot. So if I were to use these values, my highlighted ones, and then my easy pi over 6 ones, to graph sine as accurately as possible. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. And now, if that's pi over 2, right, here's pi over 3. So, again, pi over 6, that 30-degree angle, that's where you're at 1/2. Likewise, 5 pi over 6, you're at 1/2. 7 pi over 6, you're at negative 1/2. 11 pi over 6, you're at positive 1/2. So it helps you see that your graph, right, it really is, it's pretty, very cupish, right? Here, if I could graph this better. Here, looks like this. Oh, it's terrible. Looks like that. So it's, the point is to point out, it's not just like straight line up, straight line down, straight line down, straight line up. It's very curved, right? There's much more curvature to it. And then likewise, negative pi over 6 is going to be negative 1/2. Here I'm going to have negative 1. Here I'm going to have negative 1/2 again, and there at negative pi I'm back to 0. So this is graphing in a little bit more detail than necessary. Again, what you will be responsible for knowing and being able to graph is more basically just, you know, the quadrant angles, right? So pi over 2, pi, 3 pi over 2, and 2 pi are called the quadrant angles because on our unit circle, they are at 90 degrees, 180 degrees, right? They're on our quadrants. All right. So I highly recommend, if it's been a really long time, make yourself some flashcards. At least you should have this first quadrant memorized. You should know sine of pi over 3 is rad 3 over 2. You should know sine of pi over 4 is root 2 over 2. That's the easiest one, right? 45 degrees. Whether it's sine or cosine, it's root 2 over 2. So let's now quickly look at the properties of our sine function, and let's fill all this out. So what is the domain of our sine function? All real numbers. What is the range? The range is, well, it's bounded. Sine has a lower bound of negative 1, that's included in the range, and an upper bound of positive 1, which is also included in the range. So because I just said it's bounded, I'm going to go ahead and right away, hey, my bounds, is it bounded? Yes, both above and below. Y is trapped between negative 1 and positive 1. And what's the minimum value then? The minimum value is y is negative 1. What's the maximum value? The max y can be is positive 1. All right, let's go back. Is it continuous? Yes, everywhere, right? Everywhere continuous. Continuous on all x values in the real numbers. Where is it increasing? Now this one's sneaky. Okay. Because you can see it's, well, from negative pi over 2 all the way up here to positive pi over 2, it's increasing. And then it decreases. So down here for decreasing, I'm going to go and fill that in. So for decreasing, it's decreasing from pi over 2 all the way down to 3 pi over 2. And then what happens at 3 pi over 2? Well, it starts increasing again. 3 pi over 2 all the way up to, where will it peak over here? 5 pi over 2. How did you do that? Well, I'm counting by pi's over 2. Here's 1, 2 pi over 2 is pi, 3, 4 pi over 2 is 2 pi, 5 is the next one. And dot, dot, dot indicates that it's continually increasing every few intervals. Decreasing, I'm just going to say dot, 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 right? Give me one of its main intervals of increase and one of its main intervals of decrease, dot, 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 right? If you write it like this, I can see the pattern. Up, and then continuing on. So symmetry, maybe not as easy to see on this graph, but on our more general graph, absolutely symmetric about the origin. If you flip this, spin this around 180 degrees, you get the exact same graph. So symmetry is odd, and this is important. We will use this odd fact. Sine of negative x is equal to negative sine of x. That's almost like a trig identity that we use, but it's not so much a trig identity as it is a property of its symmetry. Are there any asymptotes? Nope. There's none. There are no vertical asymptotes. There are no horizontal asymptotes. And the end behavior, this is also tricky, right? As x goes to infinity, well, I'm constantly oscillating back and forth. So does y approach anything as x goes to infinity? If y is constantly oscillating back and forth, no, right? So none. I'd rather say oscillates. Oscillates indefinitely. Or oscillates infinitely. It oscillates forever. So again, the left side, there's technically no left end behavior in terms of y doesn't approach anything. So y approach, right? There's nothing that y approaches. It's continually oscillating. All right. So with that much, hopefully you can then do cosine, but quick sneak peek, right? Cosine, similar. The main differences here is if you're wanting to graph more precisely, it's pi over 3. It's the 60-degree angles, where your cosine, which is your x value in your unit circle, that's going to give you the 1/2. That's going to be nicer and easier to graph and plot more precisely. So you can see that nice precision there. Again, the main difference between sine and cosine is cosine starts at 1. So if you think about it, cosine starts at the top, right? At 0. When x is 0, you're starting at 1, and that pi over 2, you're 0, -1, 0, +1 again. So the domain and range of sine and cosine, exactly the same. Is it continuous? Yes, for all real numbers, it's continuous. Where is cosine increasing? Well, cosine's increasing from -pi to 0, from pi to 2 pi, from 3 pi to 4 pi, right? And where is it decreasing? From 0 to pi, from 2 pi to 3 pi, right? Dot, 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 dot. Cosine is even. So we're going to be using this fact when we do some trig stuff too. Cosine of negative x is equal to cosine of x. If you flip it right and left, it's symmetric about the x and y axis. You can see that right there. So beautiful, even symmetry. Again, end behavior, technically none, because y doesn't approach a single thing. It oscillates infinitely. It is bounded because the range is restricted. And lo and behold, again, where's my sine function? Well, it's right here, right? Sine starting at 0 and then going up and down, right? So cosine is just the sine graph that has been shifted over, right? So sine was basically, okay, so sine was here, right? And if I just take it and shift it over, I get cosine. And so that's why truly, if you understand sine, you know what cosine looks like too. But again, computing your trig facts is equally important. So knowing that cosine of pi over 6 is rad 3 over 2, really important to know, right? Okay, and that'll do it for our 12 basic functions.